Alright, looks like we got a little problem here. Someone's decided to sleep on my notes. So if I can't give you the homework assignment today, you can thank this guy. Alright, let's get into today's lesson. Angles in standard position in all quadrants. So yesterday we did this, angles in standard position, but we did it only in quadrant 1. Okay, now quadrants, the other quadrants, things are very similar. The biggest thing is you're going to see some difference in signs. And what I mean by that is x or y could be positive or negative. Okay, so this is the one we did yesterday. No difference there. Let's look what happens here. So the terminal side is now in quadrant 2, and so this angle is going to be a lot bigger. It's going to be greater than 90 degrees, somewhere between 90 and 180. Alright, if we get into quadrant 3, the angle will be somewhere between 180 and 270, and in quadrant 4, somewhere between 270 and 360. Okay, so that's the first thing we need to know. Alright, we went over this yesterday. There's nothing new here. Okay, cosine, sine, and tan, these were the ratios we ended up with. Okay. Now we have something called the cast rule. What is the cast rule? The cast rule tells us which trig ratios are positive. Okay, and if you think about quadrant 1, that's what we did yesterday, all the ratios are positive. Okay, if you saw that yesterday, they were all positive. In quadrant 2, only sine is positive, because if you think about the x values going this way, they will be negative. Okay, so that's why cosine is negative, and tan is y over x, so that's why it's negative. So in quadrant 2, only sine is positive. In quadrant 3, only tan is positive, and in quadrant 4, only cosine is positive. That's what these letters stand for. All positive, sine positive, tan positive, cos positive. Okay? So let's try an example in each quadrant and just see how things are a little bit different. Okay, and you'll see why those cast rules came up. So first one, this we did yesterday. We put 3, 2. That means this is 3, this is 2, and if we take Pythagoras' rule, this turns out to be root 13. Okay, now if we put theta there, sine of theta, cos of theta, tan of theta, sine is 2 over root 13, cosine is 3 over root 13, tan is 2 over 3. And you can see they are all positive. Okay, let's try quadrant 2. So negative 5, 12. We'll draw the triangle the same way. The x value is negative 5, y value is 12, and if you use Pythagoras, you're going to get this to be 13. Again, the hypotenuse is always positive. Okay, so sine theta, cos theta, tan theta for this angle. Alright, now you're thinking, wait a second, that angle's not in the triangle. Well, this is actually going to be our reference angle. We'll talk about that in a little bit, and this is our angle. Okay, so what we do is we say sine opposite over hypotenuse, cosine negative 5 over hypotenuse, and tan 12 over negative 5. And you can see these two are negative, means only sine is positive. Okay, just a quick comment. Make sure you always write in an angle, because sine without theta is sin. Cos without theta is just cos. That means nothing. Okay, it has to be of an angle. Okay, what's our third point? Negative 4, negative 3. So this is quadrant 3. So -4, -3. Pythagoras will tell you that's 5. So sine theta, cos theta, tan theta. Sine is -3/5. Cos is -4/5, and tan is -3/-4, which is just 3/4. And you can see here, tan is the only positive one. Okay, where's the angle again? Well, here is theta, and we're going to have this is our reference angle, and we'll show you how that works in a little bit. Okay, last point, we're supposed to do 6, -2. So 6, -2. Again, notice we're always going towards the x-axis. Okay, you never draw the triangle to the y-axis. Okay, it's always to the x-axis. So this is 6, -2. Using Pythagoras, you get this as √40. So sine theta, cos theta, tan theta. Our angle is here, starts at the initial x-axis, and so we have our reference angle is here. -2/√40, 6/√40, and -2/6. Now, interesting, all of these could be simplified. Okay, so let's just do that. This is going to be 2√10, and so you end up with -1/√10. Okay, this one's going to be 3/√10. Okay, and this one would be -1/3, and you can see only cosine is positive. Okay, so quick summary, that's what we just did. You can see where everything is positive. So here it's cosine is positive, so there's a cast. Here they are all positive, so it's an A. Here there is only sine positive, so we use S, and here only tan is positive, so we use T. That's where the cast rule comes from. Okay, now I talked very quickly about the reference angle on the previous page. I want to show you what that means. Okay, take a look at all of these angles. These 4 angles are what we call related angles. They are related because they have the same reference angle. So take a look at this. Our acute angle here is 35 degrees. If I draw an angle of 145, this angle again is 35 degrees. These two angles are related because they have the same reference angle. A reference angle is the angle to the closer x-axis. Okay, so the reference angle for all 4 angles is the acute angle that the terminal arm makes with the x-axis, and we should say the closest x-axis. Okay, so if we look at this angle, if we look at this angle, okay, that's 215 degrees. If we look at what is the angle to the closest x-axis, 35 degrees. Same with this one. If this angle is 325, the closest x-axis is 35 degrees. These are the reference angle. Theta R, reference angle. And in each case, the reference angle is 35 degrees. Since they all have the same reference angle, the angles are said to be related. Now, why do we care about that? Well, take a look at these 4 angles. These are similar. They're all related because they have the same reference angle. Now, if you take your calculator and put in sine of 15, you get .26. If you put a sine of 165, you get .26. If you put in sine of 195, you get negative 0.26. And sine of 345 will be negative 0.26. Because they have the same reference angle, they have the same sine value. The only thing that has changed is the sign, and the sign follows the cast rule. Okay? So, just a quick note, if we were to draw all of those angles in, this would be 15 degrees. If we wanted to draw 165, this would be 15 degrees. If we wanted to draw 195, this would be 15. And if we wanted to draw 345, this would be 15. In each case, the reference angle is 15 degrees. That's why they're related. Okay? And that should kind of make sense if you think about this. In each case, the opposite side, this is the y value for sine, will be the same height. So this is why the ratios are the same. Okay? Now, here is a little formula, but I don't think you're going to need this. I think you're going to use common sense instead. Okay? For example, let's look at this one. If I want to know what this angle is, I'm going to take 180 and I'm going to subtract what that is. Okay? That's how you're going to get those angles. We'll talk about that as we need it. Okay? Let's try a question. Okay. So let's do a little sketch. -2, -3. There's our point. Let's draw a triangle in. So this is -2, this is -3. Using Pythagoras, this is root 13. Okay, now it says determine the primary trig ratios of theta. This is not new. We know how to do this. Remember, this is theta. So sine is -3 over root 13. Cos is -2 over root 13. And tan is -3 over -2, which is 3 over 2. Now, this is the new part. Determine the measure of theta. Okay, your calculator cannot understand the different quadrants. If you remember previously, I said here, if these are 4 angles that are related, the sine value is the same for all 4 of them. Well, your calculator gets confused. It doesn't know which one to give you here. Alright, so we're going to have to use our brains a little bit to figure this out. And to do that, we're going to use what we call the reference angle. So what we're going to do is take this positive one to find the angle. So I'm going to write tan theta, but I'm not going to write theta, I'm going to write theta r. It's 3 over 2. Now your calculator can always figure out the reference angle. This is the acute angle, so in other words between 0 and 90 degrees. It can always figure that out if that's quadrant 1. And what we're going to do is tell it, well, where is that angle actually? So we're going to go theta r is the inverse tan of 3/2. Okay, and get my calculator out here. I'm going to go 3 divided by 2, and then I want to go tan. So it gives me the reference angle is 56 degrees. So that's always going to be between 0 and 90. By the way, the value you put in here, and I can't emphasize this enough, should always be positive. Always. Alright, because your calculator is looking for this angle, the quadrant 1 angle. So don't give it a negative, that confuses it. Always put a positive angle in there for the reference angle. Okay, so now let's look at our picture. The reference angle is 56. So what's the real angle? How am I going to get this angle? So I just figured out this one is 56. How do I get this one? Does it make sense that I'm going to add 180 to the reference angle? So our angle is 236. Okay? Same question. You guys try this one. Okay, hopefully you've tried it. So 3, -4, that's here. 3, -4. Pythagoras will tell you that's 5. Okay, so here is the angle. Sine theta, cos theta, tan theta. Sine is -4/5, cos is 3/5, and tan is -4/3. Now let's figure out the reference angle. Okay, now again, you could choose any one of these. Normally I'm going to take the positive one, but I just want to show you what to do if you were going to take the negative one. Okay, I'm going to find the reference angle, and I'm putting positive 4/5 here, even though it says negative. But that just tells you where the angle is. It doesn't tell you the reference angle. Remember, the reference angle is 0 to 90 degrees, an acute angle, which will always come from positive terms. Okay, so I'm going to find the inverse sine of 4/5. So 4 divided by 5. And 53 degrees. Okay, so what is my angle? What is theta? Well, again, here's my angle. I just figured out that this is 53. How do I get this? Well, maybe you're thinking I could add 180, I could add 90, and then I could add this amount. Problem is you don't know this amount. Okay? To get this angle, we're actually going to go 360 and then take away the 53. So 360 take away 53 degrees. This is 307 degrees. All right. Time for some homework. All right. Good luck with that.